Okay, we are at the point now where we want to analyze the data. So I've opened up the kaleidograph icon down here, and you'll get into this window here with the data file. And you'll start typing in your data. And then I would urge you to take the top column, double click it, and then type in what you're going to enter. So that would be 2 theta. And then this column would be counts. So we would start with something like 12 degrees, and then counts would be 120, something like that. Now I have a file that was from a previous group, and here is 2 theta and counts. You've typed it all in, and now we want to make a plot. So you go to gallery here, and it's linear, and we go to options. The option here we choose will be scatter. The scatter plot will then just plot the data points themselves. So our x-axis of the plot is going to be 2 theta. The y-axis will be the number of counts, and we make a new plot. This one is on a log scale, which we don't want. And so we click on the scale. If we double click it, we go from a log to linear. Okay, the plot colors are too light, so we need to change those. We go to plot, variable settings, and here is the marker. The marker is currently a solid square. I'd like to make it a solid circle, 12 point, and the color will be blue, dark blue. All right. I can double click the X scale. We don't need to go up to a log scale on that. That's a linear scale as well. And we will have the maximum be 130. So there is a plot of the counts as a function of 2 theta. Now to analyze this, the kaleidograph window over here allows you to click on a certain region. This is the one that does that. That just zooms in on this region here, and then you can view it on a finer scale for 2 theta. Trouble is, in order to fit the data, you have to mask the data that's at the other angles. So that's why we need to go to the masking tool, and that's this one. And there we create a rectangle. We create an enclosed region, and we blow that up like so. And now all the other data have been masked. And so when we fit the data, we will only be fitting these data here. So I can now go back to this cursor here. I want to go from 90 to maybe 110. So if I double click, I'll have 110 here. And this will be 90. All right, so there's our data. And we want to fit this to a Gaussian. So we go to curve fit. If you look at the curve fit options, the standard options are linear, polynomial, exponential, logarithmic. You can fit any set of data that you have with these functions, and it will be instant. We want to go to a more complicated fit, which is going to be either Gaussian fit for this one. Now, since the fit is a least squares fit of a function to your data, it is minimizing the deviation of your data from the fit. And so the algorithm is searching for a local minimum. And if you're not close to that local minimum, the search could take it off to infinity and you won't be able to get a Gaussian. So we have to define the parameters of the Gaussian, and at least attempt to be close to the correct parameters, and then it will refine it and give us the least squares fit. So we define the parameters, and here's our Gaussian. Our Gaussian has 4 parameters, a constant, m1, an amplitude, m2, a centroid value, which is m3, and a standard deviation value, which is m4. So m1 is just a measure of the background, and if we look at these counts, it seems to be something on the order of 200 or so. And so the m1 value from a previous fit was 750. We will just make that 200. You don't have to be perfectly close. You just have to be approximate. M2 is the amplitude of the Gaussian. So how high is the Gaussian fit going to be? It's going to be somewhere between 3,500 and 4,000. Right now it's 20,000. So we would want 3,000. So we would want e to the third. And so let me write that in there. M3 is the centroid, which is in degrees 2 theta. So the center of the Gaussian is going to be somewhere over here, and that's close to 101. So we can make the centroid from this fit be 101, 101. And then M4 is the standard deviation, which is roughly the half width about the median. So roughly this distance on this scale is about 1 or 2 degrees. M4 is already 2, so it should work. So we're done putting our guesses, and we can go to now fit. The column that we're trying to fit is counts, so we just click on that and then we run it. So I want to right now talk about some possible mistakes that you can make when you do this Gaussian curve fit. Let me go back to it. Let's find it right there. When you define the parameters, the spacing between the numbers is a semicolon. And if you somehow erase that semicolon, let's just go ahead and do that. Let me put M3 is 1 and I've forgotten the semicolon. Then I go like that, it'll give me a syntax error. And the most likely syntax error is that you've forgotten that semicolon. So you need to put that in, and then it should work. You have to click on counts because it needs to know which data file it is going to fit. If I had multiple plots here, then I would have multiple file names, so I would have to click on which one I want to do the fit. But in this case, we only have one file, which is counts versus 2 theta, so it then gives me the correct fit. And now you see that we have this really beautiful Gaussian fit of our peak. What we're interested in is the centroid, so we go back to curve fit Gaussian, and it'll ask you what you want to do. We press view results, okay? So there they are. This will be part of your plot that you would put into your image. We can look at the values here. The centroid M3 is exactly 101.12 degrees. That is the number that you would put in for 2 theta. So when you need to get the actual value of the wavelength here, you'll need the Bragg equation. So you'll put in theta. So if this is 2 theta, then theta is half of that value. And then you will use n lambda equals d sine of theta to get the value of lambda from this peak. And then that's basically it. Press OK. And we're done with the analysis. We can then make a screenshot image. We should be able to save this file. There's several options. We can save the graph as, and you're either saving it as a kaleidograph file, QPC, or you can save it as a JPEG file, say, for example, or a PNG file. And then if you do that, it will save it. You give a name to it, and then you can go and look for that name and dump that image file onto your flash drive and import that into your lab report.